For what, 200 years, there's been this hard line in the sand for algebra.
Mhm.
And in
Today, we're diving into a story that could, and I mean could, rewrite math textbooks. We're talking about a problem that's been labeled impossible for 2 full centuries and the incredible new claim that it's finally been cracked. I want you to imagine a giant, impenetrable wall in the world of mathematics. On it, there's a huge sign that says, "Do not enter. Impossible beyond this point." For 200 years, the smartest people on the planet have just tipped their hats and walked away. But what if someone just claimed to have strolled right through it? Well, that's the wild story we're getting into today. So, what exactly is this supposedly unsolvable problem? Before we can really get our heads around the new solution, we have to appreciate the wall itself. This isn't just some tricky homework equation. This is a foundational limit that has literally defined the boundaries of algebra for generations. Just look at this timeline. For thousands of years, we had this incredible momentum. Mathematicians knocked down quadratic equations, then cubic, then quartic, each one falling like a domino. It really seemed like nothing was out of reach. And then, bam, 1824. Progress just hits a solid brick wall. Everything stops. A hard limit was officially declared. And here's the name of that wall, the Abel-Ruffini theorem. Basically, it says there's no single neat formula using the usual tools, like square roots or cube roots, what mathematicians call radicals, to solve any polynomial equation of the fifth degree or higher. For 200 years, this wasn't just a theory, it was pretty much accepted as mathematical law. But hey, every great story needs a challenger, right? And now, after all this time, a new theorem has emerged to question that 200-year-old truth. And this is the mind behind that challenge, Professor Morad Sultan Izuidi. His whole argument, right here in this quote, is so simple but really profound. What if the problem was never impossible? What if we were all just using the wrong tools? So enter Izuidi's theorem. The claim here is absolutely revolutionary, that it can give you precise, exact answers for these so-called unsolvable equations. It doesn't guess, it doesn't approximate, it uses a totally new algebraic method to work from inside the equation, which means it bypasses the need for those old school radicals altogether. All right, so how on earth does it do that? To really get it, we need to put the old way of thinking and the new way side by side. Because this isn't just about a new technique, we're talking about a whole new philosophy of math. Before we even touch the formulas, there's this huge philosophical difference. Classical algebra basically said, look, this is a natural limit in the universe. We just have to accept it. Azoides' approach completely rejects that idea, what he calls mathematical fatalism. It says, no, the solution isn't out of reach. It's been hidden inside the equation this whole time. We just needed new eyes to see it. This table really breaks down the practical differences. On solvability, the word impossible becomes exact. The theory behind it shifts from those radical expressions to something new called recursive discriminant structures, which is a fancy way of saying it finds hidden patterns within the equation's own numbers. And check out the accuracy. We go from an approximation, which always has a margin of error, to a solution that is 100% verifiable. Okay, talk is one thing, but can it actually be done? Let's see this theorem in action. Let's apply it to an equation that has long been the poster child for the impossible problem. Here it is, a sixth degree polynomial. According to that old Abel-Ruffini theorem, there should be no general formula to find its exact roots. For centuries, the best we could do is just plug it into a computer and get back a messy, super long decimal approximation. But this new method promises something way more elegant. So the Izoidi method follows this really clear process. It's not about guessing or getting close enough. First, it reorganizes the equation into these neat layers. Then it uses the equation's own numbers, its coefficients, to transform itself. And finally, it just extracts the exact answer through a series of logical algebraic steps. The heart of this whole thing is this powerful recursive engine. We're not going to dive into the super complex math, but think of it like this. You feed the messy polynomial into one end, and this engine processes it using only pure algebra. It never, ever rounds or estimates. And that's the absolute key to getting a perfectly exact answer out the other side. So, what happens when you run that complicated sixth degree equation through this recursive engine? Well, after all those steps of reorganizing and transforming, the calculations for all the key symbolic parts boil down to this: a single, simple number: 0. And that leads directly to the stunningly simple solution. The exact root of that impossible equation is x equals 1. No long decimals, no approximately, just a clean, perfect whole number. It's an incredible demonstration of the claim the elegant answer was hiding inside the equation all along. So, wow, what does this all mean? If a 200-year-old wall in mathematics really has been broken down, it kind of changes the whole map of the field. Let's think about the bigger implications here. See, this is about way more than just one tricky equation. As the research suggests, this could redefine what it even means to solve something. It's a potential shift away from being satisfied with good enough approximations and a return to pursuing absolute, undeniable truth. The potential impact is just huge. This directly challenges a core belief that's been held for centuries. It could redraw the known limits of algebra and fundamentally shift the focus of mathematics back toward finding perfect, exact answers. The ultimate claim here is that no polynomial is truly unsolvable. And that leaves us with a really fascinating final thought. If a problem that was considered impossible for